You want me to Can I share the screen, Sarah?
Yes.
Okay. Let me share my screen very quickly. Uh-oh. It doesn't seem that I can share my screen, Sarah.
Okay, you can try now.
There we go. Very good. Okay. 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 Good morning, good evening, everyone. I am Jose Centeno, and I am here to in representation of the International Environmental Health Sciences Consortium. We are really delighted to have you here today for our the next webinar of this consortium. We have the honor and the privilege of having today Professor Prabhakar Sharma from India, who is going to be our invited speaker today. So we want to thank Sharma for his understanding and for his willingness to be here with us today. As many of you probably know, this seminar has been moved because of a little bit of technical problems last time, but today we are ready to share with you the research that Dr. Sharma has been working on for many years on the microplastics. But before we do this, and go into this presentation today, I wanted to take just 2 or 3 minutes to introduce to you the consortium that we actually that is sponsoring this webinar series. We are a consortium of scientists on issues dealing with environmental and health sciences, and specifically focus on medical geology in collaboration with the International Medical Geology Association. The scientific goals of this consortium is to address issues on environmental toxicology, public health, regulatory sciences, environmental epidemiology, risk assessment, and of course, the area of medical geology, which involved issues in the integration between geosciences and public health. We looked at approaches that allow us to study not only environmental health issues, but also we are focused on looking at occupationally related diseases as well, diseases that may have to do with exposure to specific chemicals or toxic materials. And this is part of how we complement, this consortium complement the goals and mission of the International Medical Geology Association, in which we bring together the address the issues of occupational health as well. So let's see if I can some of the areas that we address have to do with impacts of pollution and water quality, dealing with, for example, impact of elements such as arsenic in environmental health and public health. The example of arsenic covers not only the natural presence of this element, but also the presence of this element in both medical applications and other type of anthropogenic sources, so man-made anthropogenic sources dealing with mining or metallurgic, contaminated soils, and other type of applications where you can see this element, for example, presence and impact to environmental health and public health. The webinar is another activity of this consortium, and we have a series of presentations that have been the part of the International Speaker Seminar Series. And for the last year and a half, we have had several leading scientists in the areas of environmental health, geoscience, and public health who have discussed their research in these particular areas, from scientists that have talked from the medical use of geomaterials to leading scientists that have talked to us about the impact of volcanic emissions, for example, in public health, as well as colleagues and scientists, leading scientists that have talked to us about the presence of elements such as cadmium in soils and what is the risk assessment that we should focus on when we looked at this particular topic in environmental health and public health. And then recently, our last two speakers talked to us about the growing interest of using techniques such as geographic information systems and other type of spatial variability techniques to look at geogenic contaminants, for example, in drinking water. Today, we are very delighted to have with us Prof. Harkar Sharma. Prof. Harkar is one of our leading scientists globally in the study of particularly microplastics, the presence of microplastic in the environmental health and human health as well. He has dedicated his research to study not only the presence, but also the distribution and impact of this type of materials in the environment. As many of you know, this particular area is getting a lot of attention globally because the presence of these microplastics in our environment is increasing exponentially every day across the globe. And Prof. Harkar has been able to study this area, and today we are delighted that he's coming to talk to us about his research and how we can implement in our own perhaps regions and countries this research as well. So let me tell you a little bit about Prof. Harkar. Prof. Harkar is in the moment he's involved with the Raskish Prakriti organization. It's a non-profit organization in India who this organization is involved in looking at environmental issues and environmental education. He had spent quite a bit of time at the School of Ecology and Environmental Studies at the London University in India, and as one of the founding members of this university, he developed a master's degree program in ecology and environmental studies and set up an environmental lab to continue his research on contaminants, fate, and transport in the subsurface system, with microplastic being the focus of his research. A little bit about Prof. Harkar background. His basic degree from Stuttgart University in Germany. He has done studies at the Indian Institute of Technology and the Rajendra Agricultural University, Pusa in India. He has extensively published in the environmental literature in these issues, and also he has served and is currently serving on many editorial boards of environmental health and journals. As the director of this consortium, I am delighted today to have Sharma with us. and we look forward to many future collaborations with Prof. Harker and his work and his team. And also we look forward to continue stimulating this area of research across the globe. Let me tell you, just before we bring Prof. Harker into to present his seminar, I want to let you know about a little bit about the format of this webinar. The webinar will be recorded, so you can go back at the later time and listen more carefully to the presentation. But also you can use the material of this presentation for your own research and educational purposes. It will be posted in the consortium website, and it will remain there as part of our collections of presentations that we do in environmental health and public health. And you are free to download those type of presentations and also the materials, as I mentioned, for your education and training and research purposes. So with that, I am delighted to welcome Prof. Harker to this webinar series. Prof. Harker, thank you so much for your willingness to be with us today. For giving us the honor of having you as one of our international invited speakers. At the end of, I wanted to mention also at the end of this presentation, we will be opening the presentation for everyone to ask questions and to have kind of an informal panel discussion about the materials that Prof. Harker is going to present. So again, Prof. Harker, welcome. Thank you for giving us this honor, and we look forward to a very exciting presentation. Welcome again.
Thank you. Thank you, Professor Centeno. Can you please close this slide? Yeah, so that I can share mine.
Zaira, could you move the host?
Yes, doctor, you need to stop sharing your presentation so Dr. Prof. Harker can share his.
How do I do this? There we go. Oh.
Okay, I may start in the meantime. I really want to.
I'm trying to move this to you, Prof. Harker, but I don't seem to find
it. Should be in the bottom, probably.
Oh, I'm sorry. Let me just here.
Done.
Stop share. Okay, there we go.
Yeah.
Okay, now there we go.
Hi, if I may say something, there is another possibility in screen sharing where you can authorize all participants to share screen, but not simultaneously, and that makes it easier. Just maybe for next time. It's practical.
Thank you. Thank you.
Thanks, Teresa.
Very nice.
Thank you.
Is it visible now?
Yes, we see you. We are seeing your presentation perfect. Perfect.
Thank you very much. I first want to really acknowledge and thank the Consortium for International Environmental and Health Science because this is the very good platform for environmental researchers, not working only in the health, but also in the environment. And I really work on this area. I try to cover in my research on multiple type of pollutants like heavy metals and other area. for remediation, for understanding their interaction. And this is one of the emerging pollutants which today I'm going to talk about, that is the microplastic. So in this presentation, I will talk about how they are impacting the ecosystem. So it is more a general presentation by starting this kind of outline. So first I'll give some overview so that we can understand the plastic pollution. And then I will try to come to the definition and how the microplastics and their characteristics are different than the bigger plastics. And then switch to the impact of microplastic in the ecosystem. So I'll try to connect the different parts and how they are impacting due to the microplastic presence. And then this is the one of the area which is very interesting, that how sustainable these are, or how they are disturbing the sustainability, this microplastic pollution. So I'll try to establish some connection with the Sustainable Development Goal, and then try to highlight some of the points. Then switch to the microplastic transport. So if they are in the micro size range, then how they are impacting the subsurface system like soil and groundwater. And at the end, I will have a short case studies, which is recent work published this year on one of the location in Bangladesh, in Bay of Bengal, through one of my collaborators. And I will end with some future opportunity, research opportunity related to microplastics. So the plastic pollution and their presence. And an estimate, plastic production has reached even about 360 million tons already by 2020 in the globe. The presence of different form of plastic can occur in all the water bodies, including ocean or river, lakes, or even wetland or ponds or other water bodies. They are not only present in the water, but also in the atmosphere as well as the terrestrial environment. That means in the soil as well as in the groundwater. If we focus on the ocean, that means this marine plastic litter, which is mostly the human-created waste, that is either accidentally or deliberately become afloat in the water bodies in the ocean. So because of this, their impact, the plastic-related research are epicenter in these times. And they are even more and more being talked about. So what are some of the characteristics? So plastics, as we see every day in the household, in the office, or outside, they are generally being thrown away, washed away, or blown away and forgotten, as disappear in the ocean ultimately. The primary source of plastic in the ocean is not directly dumping in the sea, but they are basically transporting or escaping from the land. Of course, in the meantime, they travel through the water bodies, through the river, or multiple sources. So some useful basic properties of the plastic, that they are generally not biodegradable. They are having low density. That means they can easily float on the water, but they have very high strength. So they can ingested by the aquatic animals, or also they can entangle depending on what type of plastics we are talking about. So this is very common properties. Of course, it doesn't mean that they are all bad property, but this is their quality, so they become more useful, as well as they also create problem to the environment. So if we talk about the source of the plastic, then up to 80% of the pollution is land-based. So wide variety of anthropogenic compounds are becoming in the marine debris, such as plastic bags, balloon, or plastic bottle, or many more. Now, how about the microplastic, which we talk about, how do we define them? So basically, the microplastic is depending on their sizes. So what are their size range? So I'm starting here with the macro sizes. So macro sizes of plastic generally bigger than 25 millimeter, we call them. Then coming to the mesoplastic, which is in between 25 and 5 millimeter. And then if it is below 5 millimeter, then we are calling them microplastic. Then there is one more categories. If it is less than 1 millimeter, but greater than 1 micrometer, then it's called mini micro. And the remaining, which is smaller than 1 micrometer, they are called nanoplastic. So this is how it is being defined by the research community. It doesn't mean that microplastic means they have to be less than, or it should be in the order of micrometer. So for the plastic or for the microplastic, this is the definition so far we are using. Of course, there are also some debate on this about the size range, but this is commonly accepted. I will also use this one. So this red one, the range between 5 millimeter to 1 micrometer together, we are calling microplastic in most of the literature. And if it is below, then they are nanoplastic. Now coming to their types. So commonly they are called two types depending on their sources. They can be primary microplastic or can be secondary microplastic. So by name itself, it is very clear. That means if they are directly present in the environment in that particular sizes or shape, then they are called primary plastic, microplastic. But if the bigger plastics are present in the environment and if they get degraded, whether it is chemically, physically, or biologically, and then they come in the form of microplastic, then we are defining them, calling them secondary microplastic. Some of the common types of microplastic which we see here in the image are called fibers. Fibers are very common primary microplastic because they are directly being present in the water bodies or soil or other area. For example, by washing the plastic or polystyrene cloth or woolen cloth, they directly release this fibrous microplastic into the wastewater. Then the pellets are also in the small sizes. They are part of the microplastic because that size is already goes into the ecosystem or in the environment. Then the film are generally, they can be both, but mostly secondary microplastic because the bigger plastic seeds, when they degrade and then convert into the film microplastic. Fragments are also the fragmented or broken part of the microplastic, and they are coming into the environment as well by degradation, coming into the category of secondary microplastic, into my opinion, as well as a foam. Foam is like a styrofoam, lot of packing materials we use, which is very light in nature. Then the last one here I have added is called microbeads. Microbeads are again the primary microplastic, artificially has been used in many products like cosmetics or other compound. It was used more earlier, but now slowly the countries are putting ban on these type of microbeads used in the products. So this is how we can define. Now, once we know these are the microplastic, then what are the possible pathways? How they are interacting, how they are traveling, or how they are releasing into the environment. So I've divided into two parts here. These are the source of microplastic here. For example, they can come from the agricultural farming activities. We use a lot of plastic mulching. They can release the smaller particles after degrading contamination. Then industrial effluents also release a lot of microplastic, wastewater treatment plant, landfill sites, a lot of plastics or products are being landfilled generally. But with time, they may release back, or they may broken down into microplastic and come into the environment, whether it is a surface or underground. Construction activities can also release microplastic. Then household activities, including many things, clothes or other furnishing, many things can be source of microplastic. Then fishing net and gear. This is one of the common tools used in fishing industry, but they are also broken down and become a microplastic with time and pollute the environment. So basically, a lot of physical, biological, and chemical activities are happening in the meantime. And then they may also have a chances to settle down, or they may also interact with the surrounding environment. Not necessarily that they will be only transporting in the river or the water bodies all the way to ocean. So they are very likely that they can interact. For example, they can be, if it is in the water, then their fish or other aquatic animals can ingest those microplastic and can be polluted and can take part in the food chain. Or they can also infiltrate it into the aquifer or groundwater, can be present in the riverbed sediments. And also, if we use those water, which is having a microplastic content for irrigation, for agriculture activity, then naturally we are polluting the soil, as well as plant also may take. So number of activities can happen as a sink in this process as well. Now, I have tried to divide this into their impact on the ecosystem. So once the microplastic are present in the ecosystem, then there are chances that if they can contaminate, they can affect the aquatic animals directly. So they can be impacted. A lot of recent studies showing that their presence in all the aquatic animals. If they are being released into the soil, then they can alter the soil property. For example, this plastic can change the soil temperature if it is present in the soil. Or even they can change the permeability, hydraulic conductivity of the soil. So a lot of physical changes can also happen with the microplastic present in the soil. At the same time, they can be a vector for some of the harmful pathogens. That means microplastic can carry the different pathogens, bacteria, viruses, or other pollutants on their surfaces and get affected into the environment as well as the surrounding environment. Some studies also shows that they can be a magnet for other toxins. That means they can interact. The microplastic are commonly interacting with some of the toxic metals, toxic elements. So these are some of the common issues in the ecosystem. Here again, I try to highlight how they are interacting in the different ecosystem. For example, they are affecting the aquatic animals, this microplastic. Then they are affecting the water bodies, ecosystem, or even the atmosphere. So this is one of the common pathways for microplastic. If they are present in the atmosphere, then they are polluting, or from the surface to atmosphere. So both are happening for the microplastic because of their sizes, their density, their mass, and other factor. They are also impacting the soil and groundwater. Not only that, now there are a lot of focus on the food chain. That means food items are containing the microplastic. for example, in sugar, salt, beer, coke, or many other items which are having microplastic presence. So it is a big concern for health perspective. So the factor which need to be focused as a researcher, that means one should know the sources of microplastic, because for any pollutants, unless we know the sources, we cannot react, we cannot control, or we cannot understand their impact. So the source of the microplastic should also be properly known. Then their interaction. That means what are the polymer types? Because microplastic are not just one. There are a number of long chain chemical polymers, like polyethylene, polystyrene. These are all the plastic types which are being used. Then their flow condition, if we are talking about their interaction in the environment, that means how they are moving. And then one should also focus on their sink. That means how the microplastic can lead into the global ecological disturbance. Now here I try to connect the microplastic impact to the global climate change. So here we can see that atmospheric ecosystem there, then terrestrial ecosystem, as well as the aquatic ecosystem. Everywhere they are having their presence. For example, they are impacting the terrestrial ecosystem and having a loss of soil biodiversity. That means decrease in carbon sequestration, impact on nutrient cycle, as well as I said before also, that means they are influencing the soil property, that soil temperature, physical chemical condition, permeability, many things, if they are present in the terrestrial environment. If they are present in atmosphere, that means one can have the inhalation hazard. That means human nasal and olfactory problem can be created, inhibiting the pollination for the crops if they are present with the air, as well as can have a public health concern. Public health concern is basically connected to all the ecosystem here. That means they can be vector for the contaminants. For example, this aquatic foods like fishes are being taken, which is polluted. That means will create the health problem. Then one more point here, it is added called loss of viable seed bank. That means they are, some of the studies shows that they are affecting the seed germination. That means seed quality. Also, they can produce different crops, or also microplastic can goes all the way to the fruits or seeds. So more and more advancements coming into this area as well. Loss of aquatic biodiversity can happen as well if they are present in the aquatic system. So we see how they are connected, how they're impacting a different ecosystem. So now I'm coming to the 17 Sustainable Development Goals. And here this is published in one very nice paper, review paper here in sustainability by our group. And we have talked in detail how they are connected with each and every sustainable development goal. I will try to highlight a couple of them here in my presentation. For example, when we talk about the Sustainable Development Goal 14, which tell about the life on water, that means conserve and sustainably use the oceans, seas, and marine resources. They directly talk. In this one, the plastic waste can harm the marine life and ecosystem. The microplastic pollution poses a threat to the marine life, which can affect the sustainability of fisheries and tourism. Proper plastic management can reduce the amount of microplastic that end up in the ocean and mitigate its effect. So in this particular SDG, they have a special target by 2025, in one of the target group, which is having directly talking about the plastic pollution. That means index of coastal eutrophication and floating plastic debris density. So they would having a target to prevent and significantly reduce the marine pollution of all kinds, in particular from land waste activities. And this is very common that plastics are coming from mostly from land waste to the ocean, including marine debris and nutrient pollution. This will be measured by this indicator. So this is one of the SDGs where directly having link, but in this paper, I had tried to connect all the SDGs. Some of this I'm going to mention here. For example, SDG 1, which is talking about the ending the poverty in all forms to everywhere. So natural ecosystems are vulnerable to plastic waste, and they also negatively affecting the ecosystem services and livelihood, especially in the coastal communities of less developed country due to their inability to handle the plastic pollution. So basically it is affecting the plastic pollution are affecting a lot. In the second goal, which is to end the hunger, microplastic in agricultural soil, for example, vegetable, fruits, and seafood, are potential threat to the sustainable food production system and the food security. Microplastic in soil is not only a threat to soil health, soil fertility, and crop production, but also to the food security and human health. And we directly just a couple of moments before we discuss how they are impacting the soil. So here we are talking about the soil fertility can be changed, even the soil health. So which may ultimately affect the crop production. In the 8th SDGs, the proper about the decent work and economic growth, proper plastic waste management can create employment opportunity in the recycling sector and support the small businesses. This is actually very common in undeveloped and developing countries, especially. So this is a very big employment sector where a lot of rig picking happening, like collecting the water bottles, plastic bottles, and selling into market. So this is, if the recycling sector can improve, then that will be beneficial as well. Sustainable cities and communities. Managing plastic waste in urban areas can help to reduce the pollution, enhance the public health, as well as improve the overall city sustainability. In SDG 12, the responsible consumption and production. So here I explain like this, that plastic waste generate negative impact on the environment, affecting both air and water quality. Reducing the plastic waste use and managing it properly can lower the consumption and waste and promote the resource efficiency and support a circular economy. That means here we are telling about like minimize the waste as well as use them as much as possible back, recycling as well. In 13, about the climate action, the plastic waste releases harmful greenhouse gases when incinerated or decomposed in landfill. Adequate plastic management can improve these emissions and contribute to the climate change mitigation. So in the absence of proper recycling or use, this is very common in most of the places that it is being burned or incinerated directly, and which is generating huge amount of greenhouse gases. Even though it is being landfilled, it still can decompose or have affect the climate. Life on land. In 15, the plastic pollution has devastating effect on the terrestrial ecosystem, including land animals and plants that may ingest plastic debris or entangle into it. So very often we see this news that birds or even the aquatic animals are entangled with the plastic. not just in the outside, but of course they also inhale and suffocate, and death happens to the aquatic life. So not only in the water, but also in the land, this is the problem. Therefore, achieving the Sustainable Development Goal require an effective plastic waste management policy, practices, and initiative that tackle the manifested multifaceted challenges of microplastic pollution. Here I try to highlight some of the unsustainable use of plastic pollution. So I just try to start with the plastic pollution, and then I'll come to the microplastic. In this similar one, I have some specific observation about the microplastic pollution and their unsustainable use. So first about the plastic pollution. So many single-use plastic items are difficult to recycle or can only be recycled few times before they become unsustainable plastic waste. So single-use plastics are very hard to recycle, or if we recycle also, then their quality get deteriorated. So they are not up to the mark or not profitable economically, as well as for the quality which is being used, the quality for which the plastic are designed. So some of the previous study have estimated that half of the global mismanaged plastic waste is being generated by China, Indonesia, Philippines, Vietnam, and Sri Lanka. But this was not true, because they have been importing the poor quality plastic waste from high volume countries, high income countries, for recycling purposes. So this data basically are not correct, that these countries are mostly generating, but it was influenced because of this recycling happened in these countries at most of the places. So in order to resolve this, there are amendments to the Basel Convention are designed to restrict the international trade in plastic waste to curb the plastic pollution. So I think in my knowledge, this has been already implemented. Now this import-export of plastic waste has been restricted because of this agreement. So changes in industrial production and end of the life disposal can be the best form of mitigating the impact of plastic in the environment. So how can we do that? We can encourage the prevention, reuse, recycling, recovery, and disposal to have the more sustainable. Now have some specific point related to microplastic pollution, how they are more unsustainable use are happening, because it is largely been ignored. The microplastic I'm talking about the microplastic. Why? Because of this not directly visible because of their sizes. So plastic pollution are present everywhere. So that is the primary observation, and they get that's the primary target for remediation as well. So once they form into the microplastic, they are having less attention. Of course, now there are more and more emphasis happening on this part as well. So growing body of evidence of microplastic accumulation in agricultural soil, fruits, vegetable, drinking water, and seafood exists. So there are evidence now. So we have started acting on this microplastic pollution as well. So WHO has recognized the potential microplastic hazards in municipal and bottled drinking water, which largely depend on the water sources, plant design, and methods used for analysis. So although plastic bottle for drinking, plastic drinking bottle are very common everywhere, but here they are saying that probably this plastic bottle for that particular drinking water may not be the cause. If there is any microplastic in there, that means they are mostly coming from the sources from where they are being generated. Because we know that it's very difficult to remove the microplastic even in the drinking water plant or in the wastewater treatment plant. Due to their ubiquitous and persistent nature and small sizes, the health effect and toxicity of the microplastic can be recognized now as a major threat to sustainability, but still the empirical data on the ecological and human health impacts of microplastic are lacking. So although there are more and more attention on microplastic, but we still require a better mapping, better monitoring of the microplastic presence in different ecosystem, as well as their impact on human health. So studies are there which are targeting that how they are impacting the health, but not significant yet. So here in this slide, I try to summarize some of the solution which can be suggested related to microplastic. So an urgent need to move from reliance on unsustainable fossil fuel-based plastic to sustainable bio-based plastic alternative. So this is one of the recommendation, and there are a lot of research and attention are given on this area. For example, a research in Germany reported a new type of polyethylene derived from renewable oils that has greater recyclability by recovering most of the original polymers. So problem here in recycling is not only that they cost money, but also degrade the quality. So there, if one has to resell the plastic product after recycling, their cost, their quality is much worse than the original one because of multiple reasons. Not only they are changing the polymer type, but also in the parent material, in the plastic, parent plastic products, probably a lot of, that means multiple polymer types are being used to construct one product. And if they mix together, that means their quality would be different. Plus a lot of contamination also happen in between in the recycling process. Or even temperature can affect and change their polymer types. So these are the issue with the recycling. So that is also a big challenge here in recycling industry. So not only that it is there, but also if there are no use of that recycled product, then it is very difficult to convince the policymaker to or invest money into that. So recent interest in sustainable plastic has resulted in a rapid increase in petroleum-based biodegradable plastics and reduction in global consumption of fuel-based plastic. So this is one of the option here to change from fuel-based plastic to biodegradable plastic. Toxic chemicals used in plastic production hamper the effectiveness of many of these so-called sustainable solutions already mentioned here. So basically, while generating the product from any product from the plastic, lot of toxic elements are being used for whatever purpose is being used, and that is creating or hampering this sustainable solution. So the extended producer responsibility program prevention initiative to reduce single-use plastic and plastic treaty for entire plastic life cycling, including curbing production, circular economy, and environmental reporting standard, increased consumer awareness, and improved performance measures may be implemented to some extent for have sustainable plastic solution. So these are some of the observation connection with the sustainability. Now I will go a little bit of technical part here. That means why do this micro or nano size particle or plastic behave differently than the parent product? So I have used very common cartoon here to explain this, because reducing the size is basically increasing their surface area. Very simple. And more the surface area, more they are exposed to the environment, to the surrounding. That means they are more reactive to that surrounding, whether it is a chemical or physical reaction. So here we can see clearly if we are having an order of 2 millimeter sizes, for example, like a sand, then their surface area altogether are coming 24 millimeter square. But once they reduce into 20 micro sizes, like silt, for example, then 2 order of magnitude, the area is increasing. That means same product, same material, but their surface area increased 100 times. And if we go all the way to nano sizes, that means nanoplastic, then 5 order of magnitude surface area increase. So one can imagine how reactive they can be if they form the same thing into fine nanoplastic. So they can react with the microorganism, they can react with the water, heavy metal, or any other pollutant, including they can affect their health or environment more. Now, how this microplastic may transport if they are below the soil? That means if we are having a landfill site of disposed plastic product, and if they are somehow or accidentally they leaked into the soil, then they may travel all the way to the saturated zone, and then with the water flow, groundwater flow, they can impact the nearby drinking water well. So basically they can come back because they are very mobile. They can easily get transported even in the soil pores. So they can have their presence in the drinking water well. Now here I talk about some of the mechanisms, especially in the surface water. Number of things happens once they are in the surface water. So I have taken 2 season here, especially during the flood season as well as during the dry season. That means when there are enough water in the river, then number of things can happen, like they can be buoyant as well, because they are very low density. Sometimes they are lower than water, so they are floating as well, but they are in the border range. So some plastic material have a slightly higher density than water. So both are the possibility, which is a basically even bigger challenge to understand their extent and understand their impact to the environment, because they are having both density higher and lower than the water density. So they can basically attach to the surface, or with the flow of water, they can translocate from one location to other location. They can be deposited as well as they can resuspend into the water. So a lot of things can happen. Of course, that will also depend on the flow velocity of the water. If they are turbulent or if they are flowing slowly, laminar flow, then this will be different. Even in the dry season, they may have less suspension buoyancy effect, but still they can transport even on their river bed, or if they have low water, by rolling, sliding, or by deposition. Of course, I did not aid here, but even there is also possibility that they can go back to the atmosphere and have atmospheric transport together with the air. So that is also has been observed more recently. So that is also a possibility. So in the river, basically, how the fate of microplastic occur before reaching to the ocean. That means the hydrologic characteristic will be responsible in the river. The watershed pattern, physical property of the microplastics are also important. For example, whether they are fiber, whether they are microbeads, or irregular shape like or foam. So they are also having role. Hydrodynamic behavior of the microplastic will also play a role in their transport. So these are the three main processes happening in the water: buoyancy, gravity, or drag force, for transporting them all the way to the ocean. Now coming back to the subsurface soil. So these are the mechanism of their attachment. That means how they are interacting with the soil, because in the subsurface, basically soil is there as well as water is there. So, or they may be also unsaturated zone, like a dry zone where you have no water. So this is the groundwater table. And here is the sand or soil. And red color, I try to represent the microplastic. So we see here two possibilities. The one is that if they are in the subsurface or saturated zone, there is a possibility that this microplastic can stick with the sand, which is a one possibility, or they can be just in their pores, where empty pores, which is filled with water. So these two things are happening, and this is important. Why? Because if this groundwater is flowing, then only this type of microplastic particle may take part in the flow. Part of them may stay. Of course, there are a number of things which we are trying to understand here when we go in more detail. They're like chemistry, solution chemistry, pH, salt, many things play a role in this attachment or detachment. Some of this I will discuss in a moment. So these two things are happening in the saturated zone. Or what if there are some other pollutants like nutrients, for example, or heavy metal, arsenic, or anything? If they are present, it is also possible that they may stick with the microplastic surface. Of course, they are free to interact with the sand separately, but it is also possible that they are interacting with the plastic. And if these plastic particle, microplastic particles are mobile, moving from one place to other place, then all together they also can be having a movement. And of course, other chemical reaction may happen, but that is a different part. Now let us talk about the unsaturated zone here. Here the story is slightly different, because in unsaturated zone, we have a sand, but either there is a completely dry, that means air is there, or have a partial saturation, depending on when we are measuring this. So if there is any rainfall, that means they will start infiltrating. So we have some saturation, though that means a small layer of, thin layer of moisture or water over the sand. So in this case, there are two things can happen. Either they can be sticking with their sand surface, that means if they find enough thickness of the water, or they can simply stick with the water interface. That means here, what is there? New thing is here, instead of solid, here we have water this side, and then microplastic, and then air. So this means that their mobility or their fate would be completely different than this type of plastic or this type of plastic, because here there is a no contact of air with the plastic. So they may behave differently. Or similar to this, they may also have a immobile zone. That means they are having either micropores in the soil or the dead pores where there is no movement of water. So this microplastic may take part in the movement if they detach, and this will of course will move all the way from here to here and this one, but this one may be not. So these are some of the possibility about this. Now, if we try to understand their physics of this movement, then I try to explain here with three things. If there is any particle of micro size range, whether it is a microplastic or anything, this can be true for any other particle as well. So first possibility here is that there will be a Brownian motion. That means this zigzag motion of the microplastic in their empty pores or pores filled with water because of the erratic bombardment of the molecule of the surrounding fluid. So this one is there, or there can be a frictional drag force exerted on the microplastic by the surrounding force. So if they are sticking like this due to interception, that means water may try to push this type of this attached microplastic particle by a drag force. If the drag force is strong enough, that means then this particle may detach and come back into the suspension, to the solution. Or they may also just settle down by the gravity. Although in the microplastic, as I said, the density of microplastic is very, very low. And if their sizes are also low, then the gravity will be minimum. This diffusion will dominate. That means there will be more zigzag movement of the particle. But if there at least sizes of the microplastic is slightly bigger, or any particle, or if the density is slightly more, then this gravity may also affect more. That means more particle will try to settle down on their surface due to gravity. So these are all three type of mechanisms which basically occur inside the soil pores, which we have just seen. Now I'll just show a little bit about their mathematical simulation as well. So how do we estimate basically their interaction? That means how likely if two microplastic come close to each other, will they be able to stick to each other, or will they try to move away these two particles from each other? Or if they find any medium like soil, sand, are they able to stick with that surface or try to go away from the surface? All this can be understood by their interaction mechanism. So if we estimate their interaction energy, we will be able to predict what are the possibility of this particle. One more thing would like to say here before I explain. So for any surface in nature have two type of charges. Either they can be positively charged or negatively charged. And these charges become more significant if they are in micro size range. That means for smaller sizes, these are more important because they will decide whether they will be attracted to each other or whether they will be repelled to each other. One thing is very obvious here. If there are opposite charges, that means positive and negative charged particles are together, of course, they will stick to each other. They have a tendency to attract to each other. that means there will be always a attraction. But the problem is this one. If we have a similar charge, either positive or negative, ideally we think that they should repel to each other. Of course, they will repel, but it is not always true, especially if they are very close to each other or if their sizes are in the micro or nano size range. And we will just see in a moment how. So how can we do this theoretically? There are very well established equation, and it is called DLVO theory, developed by 4 scientists here. And they have defined the electrical double layer repulsion and van der Waal attraction. So what is this repulsion? Here it's depending on the diffuse or electrical double layer overlaps when the 2 charged particles approach each other. So a strong repulsion is experienced in case of similar charged particles. So this is very obvious. And mathematically also, we can estimate for any particle by this electrostatic repulsion. I don't want you to go back into detail of this equation, but I just tell you the physical meaning. That means they will be proportional to the size of the particle, which is r, that means radius. Then they also depend on their charges, which is Z and E are the valency. Then they also depend on their strength, how strong the charges are. It doesn't mean that if you have a positive charge, that means just 1. So it also varies actually how strong that positive charge is. It is different for different material. And that can be estimated by this gamma, which is inside this. And here we have a zeta potential or surface potential we call. It is part of this equation. So it is also proportional to that for both particle 1 and 2. So we are talking about 2 particles here. That is why we have written 1 and 2. And then there is one more thing here, which is depend on the exponential of kappa and h. So h is the separation distance. That means how far these 2 particles are, how separated they are, whether they are separated by 100 nanometer or 1 millimeter or micrometers. So how far they are, so that their strength of their repulsion can be experienced. So this is all together, they will determine their electrostatic repulsion. Now the other one is called van der Waal attraction. So here it is more simple, because this is always attraction, because the attractive force always exists between any particle of this micro and nano size range of same material, which has long been recognized and explained by this theory, London van der Waal force. Then force arises, this force basically arises from spontaneous electrical and magnetic polarization, which produces fluctuating electromagnetic field within the medium and then gap between them. These interactions between 2 microscopic bodies obtained by pairwise summation of intermolecular attraction. So again, there is a mathematical equation, but to estimate this for particular type of material, but I won't go in detail. So this is inversely proportional to this separation distance, again h, but they are also part of this this bracket. So it is not as simple. And one more thing here, basically important, is the radius of the particle as well as this capital A, which is called Hamaker constant, which is nothing but explaining the properties of the material or the medium, in whether they are in the water, whether they are in the salty water. That means whether the same material will have a different forces if they're in ocean or in the fresh water. So these are the things which we can have. So after all this, I'll just focus on like, if they have a similar charge, I said that there won't be always repulsion. That means they should not be always repelling to each other. They will depend on the separation distance. So this dotted line basically shows this the van der Waals attraction, which is always attraction. That means attractive force. And this is the this line is the electrostatic repulsion, which is basically having a unique shape here. So in the beginning, if they are very close to each other, that means they are also attractive force, not a repulsive force at all. But of course, here we are talking about very, very small distance, just a few nanometers. And then we have a big peak here. That means they will start to repel to each other. And then there again will be a secondary minimum where you have some attraction. So we don't want to go into detail here, but all I'm trying to say here is that there are possibility that even with similar charges, some of them may get attracted to each other if they are at this distance range or this distance range. So that is what I want to say. But this theory does not always valid for all the material types, especially the steric effects are there or elastic effect. So that is called extended DLVO. Just few points about that, and then we will go to a case study. So that is explained by non-DLVO forces. Because DLVO theory sometimes fail to explain some of the phenomena, especially the reversible aggregation. Because many times what happens, especially it is more true for this polymers, the microplastic. That means they may be attracted to each other, but they may come back into suspension. They may detach from the surface. So that is very common, and that is not being explained by this DLVO theory. So some recent advancement suggests that extra or non-DLVO energies for more detailed classification. The other factor is that structural hydration forces can be used to describe such interaction. That means this hydrophobic effect, because many times the plastics basically are hydrophobic in nature. So this is very common. That means the water is not primarily wetting their surface. So the non-DLVO, after including this, may be better explained mathematically. So that was all about this microplastic. Now I will have some interesting study. We have done connecting studies on one of the study area. So basically, high concentration of microplastic are generally being found in several coastal areas. For example, almost like 3,000 particles per kg in the sediments of North Atlantic islands in Spain was found. More than 40 million particles per kg in the sediments of Rhode Island in USA was also found in one of the study. About 78 to 140 particles per kg in the salt of Moheskeli Channel near Cox's Bazar, Bangladesh was found. So that means in the salt also it was found. Significant quantity of microplastic in Bay of Bengal via Ganga Brahmaputra Meghna River Basin in India and Bangladesh was also found. Multiple sources of anthropogenic activity basically leading to the microplastic in the Bay of Bengal and also in their connecting islands. So a lot of interest are coming into studying the nearby area in their islands. So this is one of the area which were just recently published in Science of Total Environment. So this study area is called Moheskeli Channel, which is located in Bay of Bengal of Bangladesh. So here, this is the study area which was divided into 6 zones depending on their location as well as their tributaries. It was divided to understand better. And it is also surrounded by a very crowded area called Cox's Bazar, as well as in other side, it is Moheskeli Island here. Then it is heavily influenced by monsoonal wind, mild temperature, and high humidity. Soil of the shore is muddy or clay type with varied sand and clay proportion, and it is inundated by brackish water most of the time. The sampling location were human settlement, as I mentioned, commercial settlement, salt production field, shrimp farm, plain agricultural land, and coastal and micro plantation. So this is very common strategy for sampling, which scientists are following for sediments as well as water. So in this study, also it was 14 sediment samples in 42 number. So here we used 30 centimeter by 30 centimeter quadrant. Then 12 water sample were also observed in all 6 locations with 30 number by using this mantra trawl. And density separation was used for microplastic separation from both sediment and water. Here some of the risk assessment is calculation, which I don't want to go in detail, but we also did this trying to understand the contamination factor, polymeric risk assessment, pollution risk assessment. So these are the things which are very common we do to understand their interaction. So the abundance of microplastic in this study, the average microplastic were between 7 to 138 particles per meter square in the sediments. So about 291 particles in 14 samples were observed. If you see the water sample, then it was 0.1 particle per meter cube of the water sample and about 163 in total in all 12 samples. So if we see the location, basically their concentration, then maximum microplastic were observed in the mouth of the tributaries. For example, here is the higher concentration again in this area, in this 2 tributaries, because they are releasing, accepting the water from very densely polluted area as well as some industrial effluents were coming. So these are the area where we have high concentration and lowest near the high wind or quick settlement area having lower concentration. In terms of their size distribution also was a studies, that means which size range were the maximum. So we try to have a 3 category size range here, 250 to 500 micrometer, then 500 to 1000 micrometer, and 1000 to 5000 micrometer of microplastic. And we can clearly see here there's microplastic range of 1000 to 500 micrometer are dominant in this study area, whether it's whichever the site has highest concentration, higher concentration, for example, site 14, 13, 11 are having more bigger sizes microplastic in this area. Same here for the water. In this case also, in most of the cases, this are dominating the maximum sizes, but in some cases also having slightly lower sizes. This green color is possible. In other studies also, they have a different range. For example, in one of the Polish Baltic beaches, they found less than 0.5 millimeter microplastic were more dominant. In India, one of the area in South Andaman, they found as well 0.5 to 1 millimeter are prevalent, more dominant. So the point here is that this is many times they are site specific, that which sizes are found more. We also try to understand their shape distribution. That means whether they are in fiber, foam, fragment, or film. So in this one, we have mostly observed that they are film or sheets are the dominant in both sediment and water. The purple color here, in most of the sites, the films were dominant. This might be attributed to the different anthropogenic sources of the pollution in this region, like plastic bags or other packing materials, which generally produces this film type of microplastic. In other studies, like in urban freshwater lake in China, Manas River Basin in China, as well as south coast of India, are also dominant with this film type of microplastic pollution. So there are some similarity, but sometimes some studies have other. It's completely dependent on the source types. The color of microplastic were also tried to understood in this area. And here in this study, we found for both water and soil sediment sample, this white or transparent white basically are the dominant microplastic. Almost like 50% of the total concentration, total quantity of white transparent in sediments, and about 42% in the waters at the Mohiscali channel. So this is also basically dependent on the source generation or of the microplastics. It is also important to know the types, like which type of microplastic are more common, because in this particular site, we found that most of the sites were polluted with all 5 items. But out of this polymers, polypropylene, polystyrene, polyethylene were in the higher concentration, especially in the sediment side, and in the water sample also, this polypropylene were having a significant quantity in the water as compared to other types. The last thing here is the risk assessment based on those equations. And very briefly here, I just tell you that we try to understand their interaction. That means which site are more at risk. So we found that contamination factor were maximum in this location, 14, 13, 11. So they are having at higher risk in the sediment part, in the water. This site 10 is more. Then we also try to understand that other pollution index. And similarly, we found this 2 sites are more having this pollution index factor. So these are just detailed connection with their how they are risk to the environment. So with this case study, we can conclude like this Moyes-Kelly channel of the Bay of Bengal study can provide a new insight on abundance and a spatial distribution of microplastic. So the geological location of the channel, pollution load from various tributaries, as well as the wind direction, surface current, tidal influence, and sedimentary budget were the factor which could have possibly influenced the microplastic distribution in different locations. So not all the sites have similar types, similar sizes, or similar concentration, but they are different and different location. The most common microplastic in this location were film in both water and sediment sample, and transparent white color microplastic were more prominent as well. So ultimately, the microplastic trophic transfer and bioaccumulation can cause considerable ecological damage to this particular study, as we have concluded from this case study. Now, I'll just have some opportunity for future research, some of my observation in the area where one should focus on this, the scientists working on this area, that we must focus on the fate of microplastic in groundwater, as their remediation process is very less, because for any pollutants, if they are present in groundwater, we know that it is much more difficult to remediate. So now the microplastic from some of the studies already show that it is present in the groundwater as well as in the subsurface soil. So their mapping and their analysis is very important, and it is to urgently stop and restrict the from the source. The local to global scale mapping of microplastic pollution is also very much required in future for the policymaker, and the society must act to their remediation at the local and global level for daily uses. So as I said, lot of studies are, or lot of interests are coming up in the microplastic pollution, but many times they are becoming like a site specific, just now which I mentioned in the case study. So it is very important to have a global scale understanding. That means if we know the nature of or type of the source, then we can have at least some understanding before going into detail measurement, detailed sampling, that there is a possibility to have a microplastic pollution there. So one must start with some baseline data. Then many times their standardization is also very important, because it's also depend on country to country, or the researcher who are working, they may use a different method. So some commonality, some consensus already has come up, but more is required, like a standardization of microplastic and its remediation from the environment, which is required across the globe. The adverse environmental impact of micro and nanoplastic and their standard treatment strategies should urgently be practiced by different stakeholders across the globe. So this is again a very important point, like how shall we deal with the microplastic? Now, if we know there is a presence of microplastic in drinking water, for example, so do we know like what are the concentration is allowed, or in which region, which country? So there are more guidelines are required in this aspect as well, or their interaction. Like, are they good for irrigation, same concentration for irrigation water, or not good for drinking water? So these are the issue. Should we release the microplastic after removing the other contaminants in the water to the stream or river? So these are the things are not very clear now, but of course, with time, it will come, and some are already available. At the end, I just introduce you that I have done, for example, try to find an interaction between heavy metal and plant. So we see like already their microplastic are interacting with the different heavy metals. And not only that, they are being intake by the plant as well as the fruits or seeds. And they have impact. They have health impact at the same time. So this was very short note, this published very recently. Then in terms of remediation, one has to focus more. I just had this review paper by using biochar. I tried to use biochar for remediation of other pollutants. So I thought to get updated with interaction of biochar with microplastic. So we found that microplastic are effectively removed by absorption using biochar. So it can be done. Very few or limited work has been done. Then chemical bonding and electrostatic attraction were observed in batch experiment by using biochar. Decrease electrostatic repulsion and steric hindrance reported in column experiment as well. Then microplastic in soil alter the physical properties like soil permeability and other factor, including the pH, electrical conductivity, then cation exchange capacity, and many more. So they can also have impact. They can reduce the greenhouse gases by using this. So this is just my observation. And with this, I will end my presentation. These are some of the literature which I have used mostly in this presentation. And I would like to thank you for your attention. I will be very happy to discuss with you if you have any question. This is just last week, there is a one special issue has been proposed in water journal. We are inviting the microplastic related paper into this. So you are welcome to use this and submit. Thank you very much.
So, Prabhakar, thank you so much for this fantastic, superb webinar. This is a topic that really impacts our society globally, regionally and globally. And your research really opened many avenues of collaboration in this particular topic. You have brought so many very important aspects to this topic, and so I would like to now open this webinar to questions and comments. I would like to take the first turn on this, if you don't mind, Prabhakar. I would like to ask a couple.
Sure.
Make a comment.
Please.
I would like to make a comment first, and then I ask you, just a couple of questions. First, my comment is something really aside from all the unique research that you have been doing in this topic, you have been able to combine many of the aspects that are going on today with other organizations. I am so delighted to see your discussion on the sustainable goals from the UN and how the issue of microplastic impact those sustainable goals, the implementation of those sustainable goals. As you know, the UN established these 17, I think, sustainable goals with the purpose of reducing poverty and deaths from exposure to contaminants in soil, water, and air by the year 2030. It's a very ambitious goal, but I think that your discussion on how the issue of microplastic really can help us in researching those goals is very important. And my comment here is that these goals, as you know, make a very unique link as well to medical geology, because we do have, at least from the sustainable goals that you mentioned, the number 8, 11, 12, 13, and 15, dealing from economic growth, sustainable cities, responsible consumption, climate change, and life on land and water. Medical geology impact many of these as well, because if you looked at the medical geology, you have to deal with soil and human health, climate change, adaptation to climate change, as well as life on land and water. So I congratulate you, because you have been able to make that unique link as well, and particularly on this topic of microplastic. So for those of you that are on this listening to this exciting seminar, I just want to let you know that this is a very important discussion and aspect, because it brings together the connection between medical geology, environmental health, and the goals of the United Nations for the year 2030. So that's one of the comments that I have, and of course I welcome your comment as well, Prabhakar, in that respect. So my question is this. So now my two questions. One question that I have is concerning the both the human health aspects and the environmental aspects. In terms of the environmental aspects, we are conducting research in medical geology, looking at particularly at the impact, the global impact of dust, natural dust, and dust that can come both from natural sources like volcanic emissions, the release of dust from arid or semi-arid areas around the globe. And one of the areas that we are very concerned is the composition of the dust. And for example, my research group, we are looking at the composition of dust that comes from the Sahara Desert through the Caribbean. And this is more of what we call intercontinental dust. And there's some interest in looking at the potential presence of microplastics in dust, in this kind of dust. So could you tell us if you have any particular experience on that area? What and if you do, what are the implications? What in your opinion, what could be the implication of transporting dust, and the dust being the source of global exposure to microplastic as well?
I think you have correctly pointed out this, which is very important source, in my opinion as well. So atmospheric pollution is one of the source for microplastic as well. So dust, as you said, it can be anything. It can be, of course, just soil, but could be other pollutants also they can carry. So they can also carry together with pollutants. And if they are coming from the area where they are having this microplastic pollution, which is very common generally, because microplastic are present in the air, and then they can carry together with the airflow. So, and wherever they get deposited, they can find a place and pollute the remote areas. Because I not only have seen this atmospheric pollution is impacting the land, but it is also impacting the mountain. I have come across some of the paper by others. They are trying to understand the microplastic in snow, for example. So with the snowfall, how their atmospheric and they have pointed out that atmospheric transport is the major source of microplastic in the snow. So on all type of, like, whether it is a fiber microplastic or pellets, all of them they have in their sample. So I believe this is, of course, again, we have to learn the source in more detail, because without knowing the exact source, we cannot tell about whether they are carrying the microplastic. But certainly it is one of the medium of transport of microplastic as well, because there are.
We have found some, I mean, this is preliminary, but we have found some interesting data in that atmospheric dust. And one of the concerns that I have as a toxicologist is the possibility that this microplastic could serve as a protective, environment, if you will, for pathogens, potential pathogens. There is research that we know that has been published about all the type of geochemical materials that has served as protective materials for pathogens, either plant pathogens or animal pathogens that may be found in the dust, in the atmospheric dust. So having microplastics and the different chemistries of the microplastics, this could also perhaps serve as an agent of as a protective layer for these pathogens. And of course, this will be something that have to be researched. But but as a toxicologist, I'm interested in that area as well. My other question to you is from this was more on the environmental side. When you come to consider the human health, we have seen several publications on the characterizing the presence of microplastics in human samples, body fluids, for example, in blood, in tissues. As a toxicologist and environmental pathologist, I am obviously very interested in the foreign body reaction of these materials in the body. But as a toxicologist, I have to also look at the risk assessment aspects. And when you look at risk assessment, you do hazard identification and characterization, but you also need to consider the dose-response relationship when you do risk assessment. And I don't see, or it's difficult for me to look at the dose-response relationship for microplastics in human toxicology when you don't know that that kind of dose exposure. You know what the material is, but you might not know the dose. So how do you suggest us to address that area of risk assessment, in addition to the characterization?
I don't know much about this, especially the human health aspect, but I think one has to start looking into the type of microplastic, which polymeric types are there, And that can be done via, there are tools here like microscopic FTIR or Raman spectroscopy. So they can guide us what are the polymeric types, and they have their functional groups, and one can understand their interaction with other toxic material, whether it is human blood or whether how they're interacting with other toxic element. So I think that can be started. So it is not that difficult probably, because some studies are already there analyzing this plastic in different body parts, as you said, in blood and placenta or other stool. So if we focus on their types, then we can understand them better, their toxicity as well, their chemistry.
Yeah. Thank you, Prabhakar. Any questions? Any additional? Any questions to or comments? From the audience? Any more questions?
Well, yes, I raised my hand, but
oh yeah, I'm sorry. Go ahead, Teresa.
I don't know how much time left we have.
No, we don't have time. We have time.
We have to. Well, I was listening. First of all, thank you very much. I don't know really how would be the correct way of pronouncing your name, Dr. Sharma.
Yeah, you can say Sharma, no issue.
Sharma, but would be okay.
Prabhakar.
Okay, because I love languages. But first of all, first than anything, because I am always in contact with Dr. Jose Centeno, with Jose. But I'm very delighted to see Bob there, because it's a long time since I haven't seen him really physically, actually, and here to see him on the Zoom. Because I very often tell at home that when I have finished my daily duties, I say, well, now I can sit back and relax. And that I learned from Bob. I love this expression. But as my day is very long, this sitting back and relaxing takes a lot of time for me. Now, but seriously, I'm glad to see Bob. And looking at this conference, I see I am a toxicologist, a chemist. I work in the Faculty of Chemistry. And in the last years, I was very much involved in environmental education, but thinking of our chemistry students above all, but we have also other science students in our courses, which are each year more popular. We have had to put limits on the attendance because we had so many that it was too much. But there are many things there in need of research, chemical analysis that has to be performed. I know that in that aspect, Dr. Borgel, who was attending, Audrey is very, very powerful on that aspect. She does a lot of that. We need to make the assessment. This has lots of implications, but the one which is foremost in my mind from the environmental education aspect view is that this thing of the microplastics, as so many things in medicine, we should try to prevent it. Of course, the problem is here, we must solve it. So we must make risk assessments, we must protect the health of the population. I see lots of possibilities, of course, for research, for students, for degrees, but we have to find solutions. It's not just a thing to be an interesting academic problem, which it is, but we have to find solutions. And what really I think is very important is in the preventive aspect that we do a lot, and we are already trying to do it at the educational aspect of the future professionals. For example, we in our faculty of chemistry, to know, to be aware in order to prevent this. So last year I came around the problem of the microplastics through Jose, so I am very thankful. We have already discussed these problems with our students. We have already 1 year of experience, so this year we shall continue. Maybe we can have a Zoom meeting with you, Sharma, for our future courses beginning in May, June. Maybe we can arrange something. But
sure.
the last thing I wanted to say, I don't want to be very long, is also the thing of the hope arising from what Jose mentioned, that maybe one aspect could be that these microplastics could have some protective, at least in up to a certain degree. That is something to be researched at, of course, seriously. But well, this awareness, which is always the first step in environmental education, is very important. But then we must educate ourselves to try to solve it. So thank you very much. We are going to exploit this issue in our future courses. We always receive students who want to work on certain research subjects. So this is a growing line, and I think it's very important. And well, your work is very useful in that aspect. So I promise to go on with this, and maybe I can write to you. We can see how to, well,
Sure.
Probably through Jose, it will be the easiest, because toxicology has the great advantage of being interdisciplinary. And if I am not totally wrong, but who knows best is Dr. Nelly Magnai, I think being this year 2023, it's 20 years since Nelly met for the first time with Jose, Bob, and Ule Selinos to know the new emerging field of medical geology. So it's around around 20 years, maybe it's 21, but for me it's 20, because in 2003 I began to come to know MedGeo. So, well, I will look up in our inventories to see when it was exactly. But the important thing is not the dates, but what we are doing out of it, and all that can be done and must be done. So thank you very much. I hope I wasn't too long, because I touched so many things. That is a defect of mine. I say too much of apparently unrelated subjects.
No, you didn't say too much. Very interesting, and it's always good to see you. Thanks for your kind comments.
I have your Texas boot at home standing somewhere in a vitrine.
You've made some very good points. Excellent. Thank you.
I agree. Yeah.
Thank you, Professor Teresa, for the comment and feedback. I think certainly there are a huge scope in this area. So many things we know. Of course, we know how they're impacting the health, how toxic they are if we go to their individual compound. Plus, a lot of other toxic materials are also by default being present with the microplastic because they are being used for the production. So these are the some of the detailed analysis may be required, but at least we have so far the people have established their impact in some sector, even in the toxicity aspect. So, but of course, more will need to be done. Thank you very much.
Teresa brings a great aspect and comment as well. The training and education is key for us to understand everything that is around this topic, from the characterization, the mobility, the physics, everything. Education and training is very important, and I'm delighted to know that we have people like you, Sharma, that we could contact for enhancing the offerings, the academic offerings, not only the research, but the academic offerings that we have at different universities. And what Teresa and Nelly are doing in Uruguay is unique in the sense that they are bringing medical geology into more of the toxicology as well. And so I'm delighted to know that you will be available for to consult and to help them in continue developing the curriculum for students.
It will be my pleasure. It will be my pleasure to interact with the student.
Yeah.
Okay.
Any additional comments or questions?
Just a little remark. Just a few minutes ago, I had to answer an email from our secretariat. There is someone doing a degree in her PhD studies in communication, but person who is interested in taking the course, which is a postgraduate course of advanced topics in medical geology, which covers the 2 semesters, so also the following. And I said yes, because the new insights into all the environmental issues is that the social aspects, the communication, the making known the problems is also important. So I find that another person like that, being aware on a scientific level of these aspects, can be also profit and project this these things, because microplastics will be in our next semester, as I already told you.
Great, good.
Just that. Because it came today, that's why I mentioned it.
Any additional comments for Sharma? Questions? Okay, so before we finished, again, Sharma, we are delighted to have you as one of our international invited speakers here for this webinar series of our consortium. Thank you so much for giving us that opportunity. And I want to remind everyone that both people present and people that will be watching this webinar again, that this webinar has been recorded. It will be available in our consortium website, and you can download it if you would like to show this to your students and to and use this on research. Want to make a very short announcement. Our next webinar will be May 10th. So make note of that, please. It's going to be May 10th, and it's going to be by one of our friends and colleagues from Africa. Theo Davis is going to talk to us about medical geology issues in Africa. And so it promised to be an exciting seminar as Sharma's seminar today. So please booked your calendar for May 10th at 10 o'clock US and Canada time. And we will send you reminders about that webinar as well as time approaches. My last comment to you, for those of you that are still looking at the conference, the upcoming conference of our association, the International Medical Geology Association, our upcoming conference, which will be the 10th anniversary of our conference, MedGeo 2023, will be in Monterrey, Mexico, the week of August 6th through the 9th of this year. And the conference is already receiving abstracts. So feel free to submit your abstract through the website of the conference. And if you need any information, just feel free to contact me, to contact Bob, or to contact the organizers of the conference in Mexico, Dr. Hector Rubio. Our medical geology chapter in Mexico is the host for this conference, and they are hoping to welcome you to Mexico in August of 2023. So with that, any additional questions that we may have or comments to Dr. Sharma? Teresa, do you have a comment or?
No, I said, okay, May 10th, it's Thursday again. I've seen it. And well, of course, we are thinking of the IMGA meeting. We have a very, very good